is the following. If the main theorem is the following: if R, the vector R of t, composed of the vector component f of t, g of t, and h of t, where f, g, and h are differentiable, the same definition of differentiability for a function, a real value function. F, G, and H are real value function, and then now we can write the derivative of R like so, as simply the derivative of each component. So it's very simple, but also very useful. I mean, there is really no tricks here. First example. The example today are rather trivial for most part, so nothing to get too excited about. 1 plus t cubed in the I direction, then plus t e to the negative t in the j direction, and sine of 2t in the k direction. We need to find a couple of things. A, we want to find r prime of t, and B, we want to find the unit vector where t equals 0. So the solution, if you still remember how to find derivatives, well, it will be 3t squared in the I direction. Here we need to apply a little bit of product rule, if you remember. The derivative of t times e to the negative t times plus t times the derivative of e to the negative t. So we have e to the negative t minus t e to the negative t in the j direction, and the derivative of sine 2t is simply 2 cosine 2t in the k direction. So just put a little cosmetic on this one and factor, so we have 1 minus t times e to the negative t j plus 2 cosine 2t k. As I said, nothing really to be excited about. To find the unit vector, let's t equal 0, and the unit vector of r of t was it the unit vector of r of t or r prime? The unit vector, so let me change that to of r prime. Like so. So we'll change it to r prime at t equals 0. So when t equals 0, then we have r prime of 0 equals, so we have 0i, and we have e to the negative 0 is 1, so we have j, and cosine of 0 is 1, so we have j plus 2k, and for the we need the magnitude as well, and the magnitude at 0 is simply square root of 5, so t, we'll write it as t prime at 0 is 1 over square root of 5 times j plus 2k. And we can leave it at that if you want, or if you want to play with it a little bit, say rationalize the denominator and all the good stuff, you can write it like so. That's also an answer. Okay?
T, is that prime or is that just the regular?
This is the unit vector of R that correspond to R prime.
So do you put that prime sign in or?
Yeah,
That's it?
yeah, I would. This is actually a good question. At this time, I'll take it off. There are some issues if leaving like that, so I'll keep it at that. Yeah, I'll keep it without. This is just the unit vector correspond to the tangent to the tangent vector. And the next example. This is something closer to what Jordan showed us. We have this vector, or this. Remember, those are curves described by a vector. And what we need to do is three things actually. Find first the derivative vector, and then we need to sketch R at t equals 1 and R prime at t equals 1. In this one, I want to show you how to do it on the graph program. Okay, the solution goes like this. Remember, what is the derivative of square root? 1 over 2 square root. And here we have simply minus j. So the first part was instantaneous, and now we need to sketch. So this is where I'm going to change the screen, and I'm going to, well, before I change the screen, let's evaluate. R of 1 is simply I plus 2j. Let's see, R plus j, I plus j, R of 1, right? Plug square root of 1, and then 2 minus 1, and R prime at 1 is 1/2 I minus j. So what do we take from here? How, if I want to graph this vector and write it in standard notation, what will be the vector? Well, the position vector always starts at the origin, right? You'll see that that won't be the case here for our prime. Our prime, if you remember Jordan sketch, we start with the secant and we make the difference between the 2 points closer and closer until we get to the tangent. But R by itself is the position vector. So we can say that the slope in this case will be 1, because you have the j value and the I value are both 1, so delta y over delta x is 1. So we have the line y equals x. On the other hand, here we have the slope will be -1 for j divided by 1/2 for I, so it will be -2. Okay, and now we can write the equation y equals, the point is, if you look at the point is 1 when r equals, when t equals 1, you have I plus j, and the point is xy going to be simply 1, 1. Okay, so the point is y equals 1 minus 2 times x minus 1, or it will be negative 2 plus negative 2x plus 3. So having done this, we pretty much know what we look for. So let's put it on the graph program and see what happens.